Well, folks, I just thought I'd do a little update video on the 2E26 tube transmitter, and basically I want to do a little video on the power supply that's been being used on this circuit to power the actual transmitter. And before, this power supply had a two-prong AC cord, and the cord, this power supply, the chassis was never grounded. So what I done tonight, just to make it safer, I added a three prong grounded plug to this. Still gotta get a bottom put on it, but the ground goes right to the chassis. Right, the neutral comes over to the switch, which goes to the transformer, and the hot goes to the fuse to the transformer. So that's basically all I got done with it, just to make it a bit safer. Because where this thing's a half-wave bridge rectifier, the diode is rectifying half of the AC waveform to make the DC, the high voltage plus. But the chassis of this box supplies the AC transformer is on this chassis, and that chassis becomes the negative side for the power of the circuit. So you might be able to see it. You got one red. So okay, basically, let me get something like a point here. So we got these two red wires. These two red ones are the high voltage AC from the transformer, coming out of the transformer. So one comes to the diode here. It gets rectified, so it turns from AC to DC. Right. So then this DC voltage gets supplied to the filter capacitor right here. Right. Then there's a resistor across here, a resistor across here, and then we got our DC out, which is on this side of the capacitor, which comes out plus DC. It comes out and goes in, comes out your socket, and goes to the power supply, or to the transmitter. Now, the negative, or the other side of the red wire, the transformer out, is going straight right here, across here, connected to this pin, but it's also grounded directly to the chassis. So the chassis is acting as half of the AC to the transmitter. So becoming negative to ground, basically, of the transmitter, the negative side. The two green wires, that's the filament, 6-volt filament, or heater, whatever you want to call it. That's what the green wires are. So yeah, without the ground wire here, technically the chassis is live at 160 volts on the negative side of the circuit. So chassis is live, basically. Now by putting the ground on this, then the ground goes back to the house wiring ground. So well, obviously the chassis is, live, and depending what way the grounded plug was plugged in, it can go either way. It wasn't even a polarized plug that was used, so you wouldn't even know what way to plug it in. The only way you got half an idea if it's plugged in right, if you take your finger and go lightly across the metal chassis, you can actually feel rubbery, like a vibration, kind of rubbery type of feel to it. That's how you can tell if voltage is on the chassis. You take the plug, turn it around, plug it in again, and that would disappear from this. if it was there, it's a lot less than what it was. So, well, for safety's sake, so I don't have to worry about getting electrocuted or anything else, or wires come off and touch the chassis, you know, pop the circuit breaker or this fuse. I added this a safety ground, which is this green wire to a tree grounded plug, goes back to the outlet. So, yeah, there's the fuse being used. The fuse being used. So, just figured out, and I also put the switch in here. This is not a switch. I might change this one out. I don't really like this switch too much. But, yeah. And the transformer is a Hammond. Type X262G6. Primary 115 volts, 60 hertz. Hammond Manufacturing Company Limited, Guelph, Canada. Anyway, just a little video on the power supply used and a little upgrade I've done with it. But I still got to put a cover. This is the only thing I got to get done. But this is put a cover on the bottom of this. I don't like this open like that. You're just just asking for trouble. Anyways, thought I'd just do that little video update on on this little circuit. And yeah, hey folks, 7-3, and we'll chat later. This is Reno 63. We're out of here.